Hello everyone, this is another video from Easy Electric series, and today we want to write our first program in our TWAC series Launchpad. So what we want to do, we want to actually have a one switch one and somehow connect it to the one of the I/O pins of the microcontroller, which is the switch one that you see on the launchpad. It's internally connected to the PF4. So that means we want to have a program set the PF4 as an input, able to read the value of this switch that know you push or not push. So if you push the switch, it should be turned on this LED, which is the green LED connected to the PF3 port F pin 3. So that means we want to set the port F3 as a output and PF4 as an input. So whenever we push this, it's read the input and able to turn on the output, which is PF3. So as you can see here, with pushing the switch 1, I able to turn on the green LED. Whenever I release it, it's actually turned off. So now I turn that on. Whenever I release, it's actually turned that off. So if I want to actually show you what exactly we want to do, so this is your microcontroller. So based off the launchpad datasheet, so the port F pin 1 connected to the red LED on the launchpad, PF2 connected to the blue LED, PF3 connected to the green LED. So also the launchpad has two switch 1 and 2. So if I turn on these videos, so these are actually switch 1 and this is switch 2, and also LEDs here. So in this section we have actually three LED with three different colors. So and as I mentioned, the switch 1 connected to the PF4 and the switch 2 is connected to the PF0. So that means for starting working these launchpad, your launchpad already have the switch which connected to the PF4 and 3, and also you have the LED three different color which connected to the PF1, 2 and 3, and definitely you don't need any external circuit, at least for these few projects that we want to do in the beginning. So this shows the whole story. So as I mentioned, I want to use switch 1. Switch 1 already connected to the PF4, but I want to somehow pull up these PF4 pins. What's the meaning of the pull up? So that means you make these pins one digital. What's the one digital? So for a launchpad that we have, 3.5 volt is digital 1, 0 volt is 0. So some microcontroller like Arduino, usually they are actually working with the 5 volt, so that means 5 volt is the digital 1, 0 volt is 0, but Launchpad is working with 3.5 volts, so that means the high or digital 1 is 3.5. So we keep this pull up register. What it means? So that means whenever this switch is open, this pin should be actually PF4 should be digital 1. So that means here should be 3.3 volt. Whenever you close the switch, so this connected to the ground through this ground that you see. So that means the PF4 should be 0. So switch is open. So I summarize here. Switch 1 is open. Definitely the PF4 is 3.3 volt or 1 digital. So why? Because you pull up the register. So this circuit that you see, we call that pull up resistor. So you could do that externally with the same circuit that you see. So that means connect this PF4 to the resistor and connect to the 3.5 volt. But also you could do that with the software, with initialize the pull-up register, and the pull-up register do exactly same thing. So that means it look like whenever you initialize that, it's connect to the VCC and the 3.5 volt. So you could do this with the software, or no, you could do with the hardware. So here for this case, we want to do actually use the software to keep or you pull up these pins that you see. So I summarize the whole things that we need to do. Whenever switch 1 is open, so this is open, you use the pull-up, so this is 1. So what should be happen? I want to these LED should be off. If you want to these LED would be off, what should be the voltage on PF3? So if I put the 0 volt here, so these LED is off. If I put the 3.5 volt, you have a direct bias and it's turned on these LED. For this reason, whenever switch 1 is the switch 1 is open, so I want to these LED will be off, right? So even if I actually turn on my camera, you see now I didn't push this, the LED is off. So that means PF3 is 0 digital, or that means 0 volt. Whenever switch is closed, so that means this time that I'm pushing the switch 1, so the PF4 definitely is 0 because it's connected from through this. Let I just hold this. So it's actually whenever I close the switch 1, which I did right now, so the PF4 is 0 because this ground connected to here and the PF4 is ground. What I should happen, the green LED, which is somehow is PF3, should be 3.5 volt. If this is 3.34, 3.1 volt, so definitely these LED will be on. So that's actually the summary of the whole thing. Switch is open, the PF30 or LED is off. Whenever you push these LED, so the PF4 is 0 and the 3.5 volt should be here to turn on the LED. So that's actually the whole things they want to do. So let's to actually see how you could do that. So definitely for writing the codes, you need to first initialize the registers that you have. So as we mentioned in the previous video, so the register is technically is the memory. If you want to use any hardware on your microcontroller, each of them has its own register. With initialize the value inside their register, somehow you are telling the microcontroller what exactly you want to do. So for this case, so these are the registers that we need to initialize. We need to initialize the DIR register, PUR, DEN, and RCGC2 register, and also we use the data registers. So in the beginning, as I mentioned in a previous video, so each uh, registers that you have inside the launchpad, they have 32-bit address. That means if you want to have the access to the register to reading or writing from that register, you need to use these 32-bit address. So each of them has its own unique 32-bit address. But definitely it is tough to actually all the time whenever you want to write or initialize these registers, just write the 32-bit numbers like these numbers that you see. So for this reason, we use actually the define. Somehow using define, you actually tell instead of using these address, you just able to use these names. So here I give the address of the data register and define that with these names. So that means next time whenever you want to write something inside the data like this line or this line or this line, instead of using 32-bit address, which is tough to actually use 32-bit, you just use this name, which is GPIO port F data register. It is more easier to use. Where do you find this? These actually address? It is on the data sheet of the Launchpad. This is just one time. If you just use these one time, the rest you just copy paste these actually lines, so easily you could use them by name. So that means these address that you see all actually comes from the data sheet. And be careful, this is actually whenever you say 0x means the number that comes after 0x is the hexadecimal. So if this is the hexadecimal, that means each digit that you see is the 4 bits. So you have 1, 2, 3, 4, 5, 6, 7, 8 digits. If you convert to the base 2, so each of them you represent with the 4 bits. So that means 8 times 4. This number is 32 bit in binary. So that means if you convert these numbers to the base 2, these are in base 16 or hexadecimal. If you compare to the base 2, definitely all these number is 32 bits, which is really tough to use. So that's what you have these sections. So any register that you want to initialize, you use these 5 line. You, instead of giving or their address for initialize them, you just give the name. So that means for the rest of these code, I use the GPIO port F data R, which is the data register, GPIO port DIR register, PUR, which is pull up register, DEN register, and RCGC2 register. So how they works, we are going to explain in a few seconds. But for now, just understand what you have. You actually give their address, and instead of using their address for initializing, you use a define, and somehow you define these a name for these register, and that means for the rest of these code, whenever you want to initialize the register, you don't need to use these address, you just use their name. So let's start with the first line. So definitely you actually make in this line, you are making one variable, you call the name is input, so its type is unsigned long. Why you have this? Because you want to read the switch 1 and keep its info inside these variables, so nothing new. So then you check the main part of your program. So this is actually main part between the open curly bracket and close curly bracket. So let's go and review each line. So first register that you initialize is RCGC2. You put these number inside these register. Let's see why. And whenever you initialize these number inside these register, what it means. For knowing that, you need to back here. So this is actually is a TIVA TM4C123GX6P microcontroller datasheet. It is actually free PDF file. You could actually go just Google for these name. You exactly get the same PDF file. The all info is here. So it is actually 1411 page. You don't need to read all of them. Whenever you need it, you just comes here, search for the specific part, and actually get the all data that you need. For now, I want to actually see how the RCGC2 register works. What's the meaning of that? I come here and put these PDF file in the first page and search for RCGC2. So see, it's find it here. I click on that. I go to the page which is talk about the RCGC2 register. So as you can see, the name, the run mode clock gating control register 2 is its name. So that's why it says RCGC2. So if you go down and you see how it works, so as you can see, it is 32-bit register. That's what we expect because everything in our Cortex M4 microcontroller is 32-bit. So what we did in the code, we initialized the 0x6020 inside these register. So let's see what we did. So if you write these number inside these registers, so again this is a hexadecimal number. The 0 is 40, so that means you write 40 in bit 0, 1, 2, 3 inside this register, and 2 is 0, 1, 2, 0. You write 0 here, 1 here, and 2, 0, and the rest is 0, and the all other bits is 0. Also, even you couldn't write on them because they reserve, so the only bits that you could use is 0 to 5, this one and this one. But we don't care about the others, also they are reserved. So with initialize or writing these lines, which is you see here RCGC2R, you initialize these 0x2. So let's see what's happened. You write 1 in bit 5, the rest is 0. So if you read the explanation here with writing the 1, what's happened? If you write actually 1, somehow you active the clock for the specific port. So if you write the 0, so technically you are deactive that. So that means definitely if you want to use any port, you need to actually write 1 there. So for our case, just remember which ports we are going to use for our case. We just need port F. PF4 as an input, PF3 as an output. So back to here and see how you could active port F. So if you write 1 here, it's active port A. If you have 1 here, it's active port B. If you write 1 here, port C, D, E, and F. So see, with writing the 0x020, technically you are writing 1 here, and somehow you active the clock for the port F. Without the clock, so the port not working. So that's what you should do. So that means if you use any port, first thing you need to do, you need to come to the RCGC2 clock and put the corresponding port actually 1 if you want to use it. So here we use F with writing this number inside the register. Somehow we are telling we want to active port F because we are using PF3 and 4. So go to the next register. Next register is DIR. Let's see why we write this number inside the DIR register. So again, back to here. So you actually go to the first page here and search this time for a GPIO DIR. DIR is the name of the register. So see, it's find it here for you. You click on that. We are in that page. So the DRR is stay for direction. So GPIO stands for General Purpose Input Output Direction Register, or GPIO DIR. So what we wrote there is 0x08. The first thing is whenever you put 0, you don't need to put 60. That means 0x608 is similar with 0x08 because somehow the microcontroller knows the rest is 0, okay? So I'm writing 0x08 inside these registers. See, this is what happened here. We write actually 0x0, let's see, should be, yeah, for our case we should actually write 08. I explain you why. So I changed that to the 0x, and I changed this comment because we want, based off what you see here, the PF4 should be input and PF3 should be output, right? So I'm back here. I actually changed that to 0x8. I'm explain why. So PF4 is in, that's right. It should be changed to the PF3. Okay. So now it is right. So let's see why. So I write inside the DIR register 0x actually 8. So let's back here and see what's happened. If you write 0x08, so technically 8 is 0001 in binary, and 0 means 4 other 0. The rest, just you put the 0 in all of them. So back here and see we putting 0 or 1 in bit 0 to 8 in DIR register, what it means. So you comes here and see here is explanation. Telling 0 means actually that corresponding pin is input, 1 is the output. So back to this one, which of these ports should be input? So the PF4 should be input, so that means I should put 0 there if I want to tell PF0 is input, and PF3 should be 1 because it is output based off the scenario that we have. So back here with writing 0x08, so what I did, so this is the PF0, this is PF1, this is PF2, this is PF3. I put 1 inside the PF3, somehow I'm telling microcontroller PF3 is output, and I put the 0 in PF4, I'm telling microcontroller the PF4 is input. Okay, this is exactly what I want to do. The PF4 input, PF3 output. You need to write 1 in the corresponding bit in the DR register, which telling the same thing. So here the 1 means the PF3 is output, 0 in PF4 you are telling the PF4 is input. 0 means input, 1 means output. So that's what you see why you have these 0x08 inside these DIR register. Okay, so that means you with initializing register somehow you are telling the microcontroller what you are going to do. The next register is PUR. So let's do back here and search for the next register and understand how it works. So see, I search for GPIO PUL probably, or PUR probably should be R. Yeah. So PUR. So if you back here, the name is PUR. So I found the corresponding page. So it is stand for GPIO pull up resistor or pull up select. So what it means, back to the explanation. So you have these number, if you write 0 on the any of these bits, it means the corresponding is the pull up register is disabled for that. If you write 1 means pull up register is enabled for that. So what we want to do, so we want to pull up register active for PF4, which is meaning is whenever this is open, it's keep these up. It means it keep these 1. So that means just PF, the pull up should be active for just PF4. So for that we write 0x10 in it. So let's to see what it means. Writing 0x10 in it, the first 0 is 40, so that means you put 40 here. This 1 in the binary means 130, the rest is 0. So that means you just put 1 on the, so you see again, this is PF0, PF1, PF2, PF3, PF4. So you are telling with putting 1, the pull up register should be active in PF4. So that's actually why you have this. So then you have the DN register and you initialize this value inside the DN. So let's go and see what is the meaning of the DEN register and how it's work. Again, I back to the same page. I search for GPIO DEN. So, oh, I found actually too many of them. So CDN is here. You click, go to the corresponding page. First, what is the complete name is GPIO Digital Enable. Digital Enable. So back to the explanation. So definitely it is 32 bits. So here 0 to 7 bit 0 to 0 bit 0 to 7 corresponding to PF0 to PF7. Writing the 0 means the digital function of the corresponding pin are disabled. 1 means the digital function corresponding to the pin is enabled. So which actually which actually uh, which actually which pins we want to use. We actually again back here, so we should have PF. We use PF4 and 3. So that means digital function for both of them should be active. Okay, for both of them should be active. So if I back to here, yeah, I actually wrote this before. I don't know why is the where is the what I wrote. Again, back to C, we should be right now found TN. So see 0x12, we write 0x12. Just remember this 0x12. So what is the 2 binary 2 with the 4 digits? So 2 is 0 1 0 0. What is the 1? Should be 1 here, 0 here, 0 here, 0 here. So that means which of these 0 to 7 get 1 whenever you write 0x12. So definitely should be 2, which is this one. So yeah, we need to change this one too because we want to use PF4 and PF3 based on what the scenario that you see here. So we use PF3 and 4, right? I correct that. This is the, so I correct this. So if I want to have on 3, definitely this should be 8. And the 1 is right. So that means 0x18 actually is the right one. So 0x18. Let's to see why. Because I use PF 1 and 3 based off these register, I should active them. If how I could active the pin PF3, so if I write 1 here and 1 here, I active 3 and 4. The rest should be 0. So that means 1, 1 here, the rest is 0. If I convert the binary to hexadecimal, so that means if I consider just 0 to 3, here I have 1, then I have 3 zeros, so that means I have 8. So if I take a look to the other 4 digit, I have 0, 0, 0, 1. So which is 1. With writing 0x1a, technically you write 1 here, which is somehow you active digital function for pin 3 and 4, and the rest, you don't use the rest, so you don't need them, you just put 0. Okay? So this is actually for actually the for a DEN register. So the next register that we use in here in the while loop is the data register. Let's just go and search for the data register 2. So I'm coming here and say GPIO data. So I hope I will actually data, right? I don't see that. Yeah, I already wrote some stuffs on it, so I want to, okay, I go back and actually search for data again. So let's see what else we have. Yes, this should be this one. So GPIO data, so is it here? So let I do, okay, yep. Let's just back to the codes and see what we have here. So we talk about these register and you already know with putting these value what they means here. I explain all of them here. Okay, so then you comes to the while. So while one, so this is true, so that means in your code is just repeat these while loop that you have, whatever you have inside these two curly bracket, it just repeat this because these inside the parenthesis is one is always true. So it says input. You here declare the input, then you say GPIO data register, you add that with 0x1. So what it's see in the comment, it's read the value of the switch 1. Let's to see why. So we just add these register data with 0x10. I back here, find these data register, and then we actually and these data register with these numbers. So see 0x10. Again back here 0x10. Okay, 10. I actually write that the 10 in the binary should be 4040 and 1 should be 130. So this is the corresponding pin for PF0, 1, 2, 3, 4, 5, 6, 7. I actually wrote all of them here. So if you AND these register with these number, what should be happen? Whatever you have in the PF0 AND with 0. Anything AND with 0 is 0. Same thing for PF1 AND will be 0. PF2 will be 0. PF3 AND 0 will be 0. PF4 AND with 1. The only actually bit of this register which is AND with 1 is PF4. So that means the all other bits is 0, the only PF4 AND with 1. So the PF4 AND 1, if PF4 is 0, should be 0. If this is 1, the 1 and 1 should be 1. So that means ANDing the data register with this number with 0x10, it give you a PF4. So if the PF4 is 0, so these input that you see here will be 0. So that means this AND result is equal to the PF4. If PF4 is 0, this input should be 0. So if PF4 is 1, it should be 1. So that means somehow you save the value of this PF4 inside the input variable. So if input variable is 0, it actually, you know, this switch is closed. Whenever switch is closed, actually PF4 is 0. So whenever this is open, its value is 1. So that means these line of the code somehow read the switch into the input value. Whenever it is 0, it means you push the switch. Whenever it is 1, it is 1 based off these explanation that I had here. Okay. So you AND that with the 0x10, somehow it's equal to the value of the PF4. So if this is 1, so input will be 1. So if this is 0, PF4 will be, input will be 0. So that's what the reason these input keep the condition of the switch. If this is 0, I know I push the switch. If this is 1, I know it's release the switch. So then you just need the simple if else statement. So if input is 0, what it means? Input is 0 means you push the switch. What you should write inside the register. So again, because we want to do these green LED, we actually need to make a little change here. I'm going to make that change. So see, I want to somehow turn on the green LED. Somehow I need to turn on PF3. So with writing the 0x08 inside the data register, am I actually turn on the green LED? Let to back here. So I'm writing the 0x8. So I convert 0x8 to the binary. So first 0 is 0, the 8 is 1, 0, 0. So that means with the rest is 0 because this is 32-bit. Whenever you say 0x08, somehow microcontroller knows the rest is 0, so you don't need to put 60 here on the left side of the 8. This should be enough. So if you write the 0x08 inside the data register, see which of the corresponding pins will be 1. So the PF3 will be 1 because this is only 1 that you write. The rest will be 0. So being PF3 1, 1 means 3.5 volts. So if you actually put 1 on the PF3, so it means this is 3.5 volt, and then it's going to be on, right? This is exactly what we want. So that's what you have these line here. If input is equal to the 0, so you write 8. 8 somehow write the 1 on the PF3. Writing 1 on the PF3 means 3.5 volt on PF3. It's actually turn on the LED. Else means you release. That means you didn't push the switch. So you just say else. So that means you didn't push the switch. If you don't push the switch, everything should be 0. You just write the 0x00. So that means if you back here again, you see you just write the all 0 on the 0, 0. So that means everything is 0, PF3 is 0. PF3 being 0 means you have a 0 volt here, so then it should be actually off, right? So that's actually the whole codes that you see, simple code, and this is how it's do the job. So if I actually back here and back to the Kale, so here you could see, so I write actually 0x8, actually 00. It is exactly the same code. So I build it in the Kale. So then I actually load it. So no actually error on that. So let's go and check on the breadboard. So see, whenever you have the launchpad, whenever you upload, first you need to push this button. This is a reset button. Then your circuit is ready to use. So this is switch 1. Whenever I push, it's actually turn on the green LED. Whenever you release, it's actually off. Turn off, turn on, turn on, turn off. So as you could see, the circuit, the program works, and you wrote the first launchpad program which able to turn on and off the green LED that you have on the launchpad. So I hope you like this video. Thank you for watching this video.